I'm an electrical inspector in Los Angeles. Bought an old, rundown house. He plans to renovate it and then sell it for a quick profit. He describes his job as an electrical inspector. He says it is about as exciting as gas paints. The role of an electrical inspector is crucial for ensuring safety and compliance within electrical systems. Let's delve into the core responsibilities and the technical aspects involved in this profession. The electrical inspectors are primarily responsible for examining electrical installations for compliance with the National Electrical Code, or NEC, and local building codes. This involves reviewing blueprints, conducting on-site inspections, and verifying that all electrical work meets the required standards. The inspection process starts with the review of the electrical plans and specifications. The inspector checks to ensure that the design complies with all applicable codes and regulations. This includes verifying conductor sizes, overcurrent protection, grounding systems, and wiring methods. For example, the inspector might check that the service entrance conductors are adequately sized for the calculated load as per NEC Table 310.15. After reviewing the plans, the inspector conducts on-site inspections at various stages of the construction or renovation process. These inspections may include checking the rough-in wiring before it is covered by insulation or drywall, and the final connections of fixtures and equipment. During the rough-in inspection, the inspector verifies that the wiring is properly installed, supported, and protected. This includes checking the type and size of conductors used, the methods of securing cables, and the installation of junction boxes. The inspector also ensures that all wiring is properly grounded, which is essential for safety. The inspector may use various tools and techniques to assess the electrical system. A multimeter is used to measure voltage, current, and resistance. A ground resistance tester verifies the effectiveness of the grounding system. An insulation resistance tester, or megometer, checks for insulation breakdown in conductors. The inspector also uses visual inspection to identify any obvious defects or hazards, such as exposed wiring, damaged equipment, or improper connections. Grounding is a critical aspect of electrical safety, and inspectors pay close attention to it. The grounding system provides a low impedance path for fault current to return to the source, which allows overcurrent devices to operate and clear the fault. The inspector verifies that the grounding electrode system is properly installed and connected to the electrical system. This includes checking the size and type of grounding electrodes, the grounding electrode conductor, and the bonding of non-current carrying metal parts. Overcurrent protection is another key area of focus for electrical inspectors. Overcurrent devices, such as circuit breakers and fuses, protect the electrical system from overloads and short circuits. The inspector verifies that the overcurrent devices are properly sized and installed, and that they have the correct interrupting rating for the available fault current. The inspector also checks that the overcurrent devices are readily accessible and properly labeled. Wiring methods are closely scrutinized by electrical inspectors. The NEC specifies acceptable wiring methods for various applications, and the inspector ensures that the correct wiring method is used in each situation. This includes checking the type of conduit used, the methods of supporting cables, and the protection of conductors from physical damage. The inspector also verifies that all wiring is properly terminated and connected, and that all connections are tight and secure. Electrical inspectors must have a thorough understanding of the NEC and local building codes. They must stay up to date on the latest changes and revisions to these codes. They must also have excellent communication skills, as they often need to explain code requirements to contractors and homeowners. In addition to technical knowledge, electrical inspectors must possess strong ethical principles. They must be impartial and objective in their inspections, and they must not be influenced by personal relationships or financial incentives. They must also be able to make sound judgments based on their knowledge and experience. Some common electrical code violations that inspectors often encounter are improper grounding, undersized conductors, incorrect wiring methods, and lack of overcurrent protection. In addition, inspectors may find violations related to the installation of electrical equipment in hazardous locations, such as flammable storage areas or damp environments. To become a certified electrical inspector, individuals typically need to complete an apprenticeship or other training program. They must also pass a certification exam, which tests their knowledge of the NEC and local building codes. Continuing education is often required to maintain certification, as codes and regulations are constantly evolving. The role of an electrical inspector is essential for ensuring the safety and reliability of electrical systems. Their work helps to prevent electrical fires, shocks, and other hazards. By enforcing electrical codes and standards, they protect the public and contribute to the overall safety of buildings and infrastructure. The electrical inspector verifies that electrical panels are installed correctly, ensuring proper labeling of circuits and breakers. This helps to prevent confusion and makes it easier to identify and isolate circuits for maintenance or troubleshooting. The inspector checks the panel's grounding and bonding connections, ensuring that they are secure and properly sized. The inspector also verifies that there is adequate working clearance around the electrical panel as required by code. This clearance provides safe access for maintenance and repairs. Inspectors examine the installation of lighting fixtures, ensuring that they are properly supported and wired. They check for any exposed wiring or damaged components that could pose a safety hazard. The inspector also verifies that the lighting fixtures are suitable for their intended location, such as damp or wet environments. Inspectors also check the installation of receptacles and switches, verifying that they are properly grounded and wired. They ensure that tamper-resistant receptacles are installed in areas where children are present. The inspector also verifies that ground fault circuit interrupter, or GFCI, protection is provided in areas where receptacles are located near water sources, such as bathrooms and kitchens. The installation of electrical equipment, such as appliances, HVAC systems, and generators, is also inspected. The inspector verifies that the equipment is properly grounded and wired, and that it is installed according to the manufacturer's instructions. The inspector also checks for any potential hazards, such as exposed wiring or damaged components. Inspectors may also conduct inspections of existing electrical systems to identify potential safety hazards or code violations. These inspections are often performed as part of a real estate transaction or when a homeowner is planning a renovation. The inspector will provide a report outlining any deficiencies that need to be corrected. During an inspection, the electrical inspector will verify the ampacity of conductors. Ampacity refers to the current carrying capacity of a conductor. The NEC specifies the ampacity of different types of conductors based on their size, insulation, and installation conditions. The inspector will use tables in the NEC such as Table 310.15 to determine the allowable ampacity of conductors. The inspector will also consider any dirting factors that may apply, such as when conductors are installed in conduit or bundled together. Dirting factors reduce the allowable ampacity of conductors to prevent overheating. The electrical inspector will also check the voltage drop in conductors. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. The inspector will use calculations or tables to determine the voltage drop in a circuit. The inspector will consider the length of the circuit, the size of the conductors, and the load current. The electrical inspector will also check the short circuit current rating, or SCCR, of electrical equipment. The SCCR is the maximum short circuit current that a component or assembly can safely withstand without sustaining damage. The inspector will verify that the SCCR of electrical equipment is sufficient for the available fault current at its location. The available fault current is the maximum current that could flow in a short circuit condition. The inspector will use calculations or fault current studies to determine the available fault current. The electrical inspector will also check the equipment grounding conductor, or EGC. The EGC is a conductor that provides a low impedance path for fault current to return to the source. The EGC is connected to the grounding electrode system and to the metal parts of electrical equipment. The inspector will verify that the EGC is properly sized and installed. The size of the EGC is based on the size of the overcurrent protective device. The electrical inspector will also check the bonding of metal parts. Bonding is the process of connecting metal parts together to create a low impedance path for fault current. Bonding helps to prevent electric shock hazards. The inspector will verify that all metal parts that are likely to become energized are properly bonded. This includes metal conduits, metal enclosures, and metal water pipes. The electrical inspector will also check the wiring of electrical boxes. Electrical boxes are used to enclose and protect electrical connections. The inspector will verify that the boxes are properly installed and supported. The inspector will also check that the wiring is properly connected to the terminals in the box. The inspector will also check the use of proper strain relief techniques within the electrical box. The electrical inspector will also check the installation of smoke detectors and carbon monoxide detectors. Smoke detectors are required in all dwelling units to provide early warning of a fire. Carbon monoxide detectors are required in dwelling units that have fuel-burning appliances or attached garages. The inspector will verify that the detectors are properly located and installed. The inspector will also check that the detectors are working properly. The electrical inspector will also check the installation of arc fault circuit interrupters, or SIs. SIs are a type of circuit breaker that protects against arc faults. Arc faults are dangerous electrical faults that can cause fires. SIs are required in certain circuits in dwelling units, such as bedroom circuits. The inspector will verify that SIs are installed in the required circuits. The electrical inspector will also check the installation of surge protective devices, or SPDs. SPD protect electrical equipment from voltage surges such as those caused by lightning. SPD are often installed at the service entrance of a building. The inspector will verify that the SPD are properly installed and grounded. The electrical inspector needs to stay up to date with new technologies. Firstly, there are solar photovoltaic, or PV systems. These systems convert sunlight into electricity. Inspectors verify that solar PV systems are installed in accordance with the NEC and other applicable standards. This includes checking the wiring, grounding, and overcurrent protection of the system. Secondly, there are electric vehicle, or EV, charging stations. These stations provide electricity for charging electric vehicles. Inspectors verify that EV charging stations are installed in accordance with the NEC and other applicable standards. This includes checking the wiring, grounding, and overcurrent protection of the station. Thirdly, there are smart home systems. These systems allow homeowners to control various electrical devices in their homes remotely, such as lighting, thermostats, and appliances. Inspectors verify that smart home systems are installed in accordance with the NEC and other applicable standards. This includes checking the wiring, grounding, and overcurrent protection of the system.